All right, welcome back. Gonna do the next or do a problem. I've gone ahead, I've written out the equations, and let's go ahead and do a problem. So number 8 says, this is number 8 from your textbook, is 3x squared plus y dx plus x squared y minus x dy equals 0. Okay. Now, one thing I want you to notice, we're going to introduce this as a solution, but one thing I want you to notice is that x being identically equal to 0 actually solves this. Remember, we can have x here as a function of y as well, because this is an implicit solution. Okay, so let's just imagine that x was identically equal to 0. This would be 0, right, because of the zeros here, but then also the dx is 0, because x doesn't change. So this would be 0 plus 0 equals 0. Okay, so it's another way to sort of see that as a solution. Okay, but let's start doing the integrating factor technique. So we're going to start by taking p of xy equals 3x squared plus y. Q of xy equals x squared y minus x. Okay, so now let's take the partial of p with respect to y equals 1. Partial of q with respect to x equals 2xy minus 1. Okay, so now let's try to set up both of these equations. Now I'm going to do the one that doesn't work first. This one doesn't work. And I'm going to show you why it doesn't work for us. Okay, so let's do this one first. Keep in mind, it's not going to work. But we don't know that a priori. We don't know that yet. Okay, I only know it because I just did the problem. Okay, so, oh, I need to change these. I did it over here. I forgot to do it here. These actually become total derivatives because we've assumed that this is just a function of one variable. Okay, so watch what happens when I do this. Let me do it in orange over here. D mu dy equals negative mu. Now, over here, partial of p with respect to y is 1. Partial of q with respect to x is 2xy minus 1. So when we do 1 minus 2xy minus 1, and then we're going to divide it by p, 3x squared plus y, we're going to get to an equation, d mu dy equals negative mu 2 minus 2xy divided by 3x squared plus y. Okay, so now we can see this is a problem because this equation only has mu and y in it. And this equation all of a sudden has some x in it. We don't want that, okay? So the x here is bad. And that tells us we're not going to go down this road. Okay, so let's try the other one. Okay, so if we go with this one, we're going to take d mu dx equals mu. Now, partial of p with respect to y minus partial of q with respect to x. We actually already did that. That's going to be 2 minus 2xy. That's the same as this thing here. But now what are we dividing by? We're dividing by x squared y minus x. Again, that doesn't look as good. That has a y. But wait, power of algebra. Let's strikes again. So d mu dx equals mu times, let's factor out a 2, and we get 1 minus xy. And if we factor out an x, we get xy minus 1. And look at that. The y magically factors away. We weren't going to get that happening over here. Okay? So it magically factors away to be d mu dx equals mu 2 over x. Okay, now we should know how to solve that by now. If not, here's a refresher. D mu over mu equals 2 over x dx. Natural log of mu equals 2 natural log of x. Hold on. I made a mistake, but it's not unfixable. Should have been a big old negative sign here. Not. Which gives us, see, because I knew what the answer was, so I knew the negative sign had to be there. It always helps knowing the answer beforehand. Okay, so the negative sign there. Okay, so mu is going to end up being 1 over x squared. So now, this is our integrating factor. Okay, so we're going to take this, the 1 over x squared, and multiply it by our original equation. Let's take our original equation. Okay, let's take our integrating factor. Okay, so we're going to multiply this equation by 1 over x squared. So we're going to get 3 plus y over x squared dx plus y minus 1 over x dy equals 0. And now we can do our integrating both sides. So our f of xy equals, taking this integral with respect to, we're going to integrate that with respect to x, right? So that's going to be 3x minus y over x plus some function of y. This one, we're going to integrate that with respect to y. So that has to be y squared over 2 minus, notice this term is going to be y over x, which matches with that term. Okay, plus some function of x. So we get, putting them together, there you're going to have, of course, the negative y over x, the 3x, and the y squared over 2. Okay, so you have y squared over 2 plus 3x minus y over x equals a constant, or you could also have x being identically equal to 0. Okay, all right, we'll do another one in a bit.